Hello students, so today we will be discussing carrying capacity. Before going into the discussion, I would like to first discuss with you about this carrying, this particular task. What term you remember first after the carrying? Carrying bag or something like that? So if we just bring that analogy of a bag which we always use for many different purposes. Sometimes you carry only small purse. It is having its own capacity. Sometimes you are using a very huge suitcase which is having a completely different capacity. So it depends. That does not mean that you don't need a purse which is having, that purse is having a very small capacity, so you don't need it. No. Every carrying packages are having their own niche necessity. So that's the way we would like to understand this carrying capacity of each different ecosystem bags probably. So are you getting me that you are using that carrying bags depending on your need, then you are changing it. So each such bag is having its own limit. Within that limit, it is having its capacity to carry and you choose it accordingly. Are we doing the same thing when we are going into the urban ecosystem? That's the thing we are going to discuss today through this carrying capacity. So today we will be discussing carrying capacity, types of urban carrying capacity. We will discuss broadly the models and approaches to assess carrying capacity, and we will discuss two interesting case studies to see how these models and approaches are being applied. One case study is from India, environmental and urban carrying capacity assessment from Agra. Another one from China, that is Zhejiang province, urban comprehensive carrying capacity. Both the papers are having their own strength, and I believe they will attract your attention when you will do your own study in the carrying capacity area. So what is carrying capacity? All of us, we do understand carrying capacity. I believe we were just recently discussing the bag. Now let us see how on the scientific platform this concept was discussed. This concept was first developed by Thomas Malthus in the year of 1798, long back. So carrying capacity is the maximum population. This population can be human, the population can be any other biotic one under any natural ecosystem. So it's the maximum population that a given area can sustain. Measures commonly used include the number of individuals or the total biomass of a population. So either you can go for a numbers individually or total biomass what they are creating, which are each highly dependent on differences in physiology and age structure among species and across large taxonomic groups. If I am going for a big mammal and I am having small insect, population wise, I need maybe thousands of insects to have a similar space being occupied by one single African elephant, isn't it? So we have to also be very alert on the total understanding of this carrying capacity. It's not only the number, it is also physiology and age structure among the species. Carrying capacity, why we discuss this carrying capacity? We have seen its very important practical necessity. When resources are reduced to extreme minimum and carrying capacity has decreased, repercussions result, and that results in a crisis in air and water for all living beings, and that reduce the human population under acceptable limits. If any particular city is facing this type of air pollutions or water is scarce, then definitely the people who are having opportunities, they will leave that city. They will try to move out of that city and will go to another place. So the carrying capacity is also having these other aspects. Extreme events like epidemics or pandemics, natural or man-made disasters, they worsen this particular scenario further. Now see this particular image here, carrying capacity. One side I am having the time dimensions, the other side is the population dimension. For any particular land, the carrying capacity normally will be a static horizontal line for that set. You can have a stable population which will grow up to certain limit and then it will be going along with the carrying capacity threshold. But what we can do, we can also enhance that carrying capacity in certain means. It can be regulatory means, it can be economic means. In that case, the carrying capacity of that place can go up. Also, we have to understand another concept here, that this particular carrying capacity can be degraded if the scenario is not suitable, or it can overshoot also. You go beyond the carrying capacity, then you come down. So all these scenario can happen to the carrying capacity for any particular parcel, land parcel. The urban carrying capacity can be defined as the level of human activities, population growth, patterns and extent of land use, physical development which can be sustained by the urban environment without causing serious degradation and irreversible damage. That is important. So, we will be now discussing the types of this urban carrying capacity. First, I would like to seek your attention to biophysical ecological carrying capacity, socio-technical carrying capacity, socio-economic carrying capacity, institutional carrying capacity. Biophysical ecological, it represents the natural system thresholds, the foundation of all other capacities. Under this, we can group three major carrying capacity concepts: physical or spatial one, ecological or environmental one, biocentric carrying capacity. So, these three. Under the socio-technical, which represents infrastructure systems translating natural limits into service delivery. So, you are actually adding certain things, so you are inviting more, you are extending that carrying capacity through your intervention, that is infrastructure here. So, we discuss infrastructure or service carrying capacity, which comes under the socio-technical. The next category is the socio-economic, which represents human and economic responses to those system limits. And two different urban carrying capacity typology will come under this. One is the social carrying capacity and the sixth one is the economic carrying capacity. And the last set is the institutional one, which represents governance capacity, which moderates, integrates and enforces the balance among all domains. And this is called as institutional or administrative carrying capacity. So, these are the four major types under the urban carrying capacity, and within that we could find 7 types. First, biophysical ecological carrying capacity we will be discussing. Biophysical, we said that there will be 3 different typologies we will be discussing under this. First one is the physical or spatial carrying capacity. What does that mean? Maximum population and activity levels that available urban land and spatial configuration can support. Very simple definition and very basic one also. So how we can really measure it? The indicators are FAR, buildable land, density threshold, urban sprawl extent. These are the indicators. The second type is the environmental or ecological carrying capacity. Very important. We cannot only do the physical carrying capacity. And what this particular carrying capacity discusses, the maximum level of human activity an ecosystem can sustain without degradation of air, water, soil, and biodiversity. Very important. And that is something which I think in today's time, Indian urbanization shall remember. And what are the indicators here? Air quality index, water quality, green cover, heat island intensity, all this comes under this environmental or ecological carrying capacity. The third one is the biocentric carrying capacity. This is the limits defined by the needs of non-human life. That's one particular philosophy which we need to really remember again and again. In the urban areas, we always give preference to the human beings, but we have to have consideration for non human lives. If not for them, but for ourselves, that's also okay. For us only, we need them. So, preserving the biodiversity, habitat integrity, and ecosystem ethics. What are the key indicators? Habitat fragmentation, species richness. These are the very important key indicators for biocentric carrying capacity, where all other lives are important. Now we are coming to the socio-technical carrying capacity, which we already talked about, and we said infrastructure carrying capacity. That is going to be discussed. What is the definition of the infrastructure carrying capacity? The ability of urban utilities, water, sewage, solid waste, energy, transportation, etc., to meet demand without failure. That's very important. It will not only meet the demand, but without any failure, it will continue to serve. What are the indicators? Water supply ratio, sewage capacity, network LOS. Now we are coming to socio-economic carrying capacity, the third category. And here we will be discussing two different types, social carrying capacity and the economic carrying capacity. Social carrying capacity is defined as the level of crowding, congestion, tourism, and noise tolerated by residents without loss of quality of life. And which are the key indicators? Noise levels, congestion index, resident satisfaction. And in today's time, most of the touristic places are actually going beyond this social carrying capacity, and the residents are coming out. They are very clear that they don't like that, and they are actually blocking roads. They are not allowing the tourists to come in the city. If the governance, local governance are not helping, then they are taking it to themselves, that task that they are not allowing, because they have to also live there. Their quality of life is important as well. So, this is a very common thing which is happening in today's time. Even in India, all touristic places are really so much overcrowded. So, it's not only risk, but it is also hampering the lives of residents. Economic carrying capacity or sustainable resource flow carrying capacity, and it is defined as capacity to maintain long-term flows of essential resources, energy, water, food without depletion and economic decline. Per capita energy use, renewable resource share, they are the good example of it. Next is the institutional carrying capacity. In this, we will be discussing institutional or administrative carrying capacity. How to define that? The ability of governance system to enforce regulations, manage land, issue permits, monitor pollution, and implement policy. Very important one. It is not only land based, the physical one. It has to have all these dimensions as well of the carrying capacity. Then only that urban ecosystem will have a balance. So, what are the key indicators? Policy compliance rates, budget adequacy, regulatory enforcement. These are the key indicators. Only having the regulations, rules doesn't matter. You have to implement them. Until and unless implementation has happened, any good rule is as good or as bad as any bad rule. So, let us see the models and approaches to assess this carrying capacity. So, we will go one by one. Biophysical, ecological carrying capacity. Under that bracket, we discuss the physical or spatial carrying capacity. The models or methodologies used to understand this carrying capacity are uni-constraint model, which identifies limiting factor of land or water like that. Then the other model is graphical model. Through this model, you can visualize the visual thresholds. The third one is the energy analysis model, which provides us the understanding of the resource and energy flow balance. The key focus of this particular type is, as we discussed earlier also, land use, density, water and space limitation. The next carrying capacity we will be discussing is the biocentric carrying capacity. Sustainable accommodation through feedback evaluation, SAFE model. This is quite often used model for this carrying capacity, which talks about the feedback based sustainability balance among biophysical and social systems. There is also another very interesting one, that is the comprehensive index evaluation method. Combines biocentric and anthropocentric indicators. And the focus is nature-centered sustainability and ecosystem integrity. And the third one, actually I have discussed this particular type as a second one in previous slides. So, this is the environmental or ecological carrying capacity, and here the methodologies or models used are the PSR, very common model, pressure state response. That model looks at the cause, effect and response structure. Then the second method that is also very common, that is dynamic indicator method, DIM, time based tracking of ecosystem indicator. As a temporal one. You look at it because ecology, seasonally it may change. Third one is the Gray prediction model, GM11. It's a forecasting model. It focuses the ecological state with limited data. Whatever existing data it is having, based on that it predicts. And the fourth one, probably all of us we have heard it, ecological footprint model, which quantifies resource demand versus the biocapacity. And the key focus of this environmental and ecological carrying capacity is environmental quality, assimilation, resilience. Socio-technical carrying capacity, infrastructure carrying capacity, energy analysis model, resource efficiency and supply demand balance. We can do with this. Entropy weight method, data driven weighting for multiple infrastructure indicators. And comprehensive index evaluation combines technical and performance indicators for the infrastructure. And also we will be discussing another one, that is cross link with spatial systems, infra plus spatial, where we can discuss the models like coupling coordination degree, examines interdependence between infrastructure, environment and economy. And obstacle degree model, ODM, it actually looks at the barriers, challenges. It identifies limiting or underperforming infrastructure components. So, for the Infrastructure carrying capacity, the key focus is service provision, whether it is water, transport, energy, waste, that is very important. For the cross-link, we can see the integration of land and service networks is the key focus. And you can see here in this particular slide that comprehensive index evaluation we have also discussed when we have discussed the biocentric carrying capacity, where our focus was biocentric and anthropocentric indicators. And in this particular case, in the infrastructure, we are looking at technical and the performance indicator. So the same model are going to be utilized for different type of carrying capacity assessment as well. And the next one is the social one, socioeconomic and perceptual domain, social carrying capacity. Again, the comprehensive index evaluation method, just now I was discussing. This time it is integrating perceptual and livability metrics. Again, that SAFE model, but here it is including feedback from human satisfaction and social systems. And there it was physical one. Dynamic indicator method, which is now tracking shifts in perception and livability over time. So when I am doing the social carrying capacity, my focus is different. So accordingly, the model will also be utilized in a different with different inputs and outputs I will get. Focus areas, tolerance, crowding, livability, satisfaction, etc. The socio-economic, the second part is the economic. So let us see now economic or sustainable resource flow capacity. IPAT equation, which links I stands for impact. Impact to population, to affluence, to technology. So IPAT, that is IPAT equation. Coupling coordination degree, which was looking at the correlation. This measures synergy among economic, social and environmental systems. And the obstacle degree model will be looking at the challenges. That is looking at the, in this case, identifying the key economic constraints. Let us see the key focus areas when it is economic carrying capacity. Per capita energy use, renewable resource share, etc. becomes the key focus. The last one we will be discussing, that is the institutional and governance domain carrying capacity. Institutional or administrative carrying capacity, we will be using the SAFE model where the institutional feedback and regulatory responses will be integrated. We will be using again the pressure state response. Here explicitly includes the response as governance action. Thus the response we are looking for. Coupling coordination degree, here we are examining policy coherence and system integration. In the obstacle degree model, this will highlight the governance or administrative bottlenecks. What is the key focus? Planning and governance effectiveness. The last one is the temporal one, adaptive or resilience capacity. Dynamic indicator model, here it is going to look at the time-based resilience that it will monitor. Polygon composite indicator method visualizes multi-dimensional sustainability change over time. And the last one is the entropy weight method. This tracks shifting weight as systems evolve. Its focus will be evolution, adaptability, long-term sustainability. So these are the models which we have discussed. Just see 14. And once we try to look at from the grouping of this carrying capacity, biophysical, ecological, socio-technical, socio-economic and institutional, it's not sacrosanct. Some others are also coming under socio-technical, but broadly these are the models we have discussed under them. Now come to the very interesting part of today's lecture, that is the case studies. First one is Agra. As I said, the carrying capacity was assessed using the SAFE model. Study area was identified Indicators were identified. Those indicators were classified under environment, resources, infrastructure, and ecology. Then the great calculation of the indicators happened, and the land carrying capacity was calculated based on the SAFE model. Strategies, whatever that analysis could bring forward, based on that, strategies were being suggested. This model identified extensive non-developable areas including water bodies, heritage buffers, drainage channels, and environmentally sensitive zones, limiting horizontal expansion, infrastructure footprints such as transport corridors, waste treatment facilities, and institutional spaces, further reduce the usable urban land. So, it has gone for the FAR regulation, and SAFE estimated that Agra is approaching overshoot in population under the projected growth conditions. To complement the land-based capacity estimates, that's the SAFE model, dynamic indicator model as well as polygon composite indicator method also used. They evaluated performance across resource, environment, infrastructure, and ecological subsystems, which were the indicators here. You just see environment, resources, infrastructure, and ecology. The result shows that resource carrying capacity ranked the poorest. Environmental quality and ecological capacity is also no such good, but infrastructure performed moderately. What visual polygon helped? That revealed the imbalanced subsystem development and declining indicator values in the central wards, which are highly dense. High tourism pressure exceeding 10 million visitors per year for Agra, that is intensifying the waste generation, water stresses, and air pollution. And the interventions were recommended, which is including groundwater recharge, river water quality, urban green expansion, waste management, and planning the satellite settlements to relieve the core load area. So, you extend the area so that the carrying capacity of those areas can be utilized. So, which are the models it has used? We discussed SAFE model, DIM, and the polygon composite indicator method out of that 14. Now, the next one we'll be discussing today is the Zhejiang province, China. As the time will be very less, so probably I will discussing it very first, but all of you please go through it, especially look at this particular source. You will enjoy the case like anything if you are interested to understand how the carrying capacity can be computed in composite in a very complex urban areas using the UCCC. This is Urban Comprehensive Carrying Capacity. Here that capacity was estimated using the Production Living Ecological PLES framework to evaluate how industrial output, residential services, and ecological protection interact across the cities. So, this was the chart. This is the data side. The data was collected for the urban comprehensive carrying capacity, and entropy method was utilized to normalize those data because data is of different types. Then production space carrying capacity P, living space carrying capacity L, ecological space carrying capacity PLE, all the space carrying capacity was computed. Then urban comprehensive carrying capacity UCCC, that was computed, and coupling coordination degree model, those indicators here, whatever indicators were used, those indicators were actually tested through this coupling coordination degree model to understand their coordination, alignment, and obstacle degree model helped to understand the constraints, and Gray prediction model help to understand the future. So, that's the way the development proposals of Zhejiang municipalities, they got all this information from this particular comprehensive carrying capacity estimation. This comprehensive index evaluation method was used to integrate normalized subsystem, which I discussed here, and this score into single capacity index supported by entropy weighting to assign objective indicator weights. Then the coupling coordination degree, as I discussed, then the obstacle degree model, which was actually utilized to identify the challenges like land resource scarcity, pollutant emissions, green space fragmentation, etc. Grade prediction model forecasted the future plateau in carrying capacity indicators, warning of saturation under current development intensity. So, business as usual is not the best model to go for certain different thing. So, results showed that cities with strong production capacity exhibited ecological deficits, whereas mountainous counties they maintained the ecological strength but weaker living condition. So, the policy recommendation include reducing land consumption intensity, expanding urban ecological corridors, controlling industrial emissions, enhancing public services in mountainous regions, and promoting grain industry clustering to reduce the cross system pressure. So, this is the agglomeration which in the Hangzhou Bay region that displayed relatively high comprehensive capacity due to coordinated economic infrastructure and livability improvement. So, once we have completed the discussion of the second one, you can see we have also added comprehensive index model, gray prediction, coupling coordination, obstacle degree model and entropy weight method. So, another 5. So, just see only through 2 different examples we could learn the importance and applicability of these models and approaches. 8 out of 14 already we have seen in these 2 cases. So, I will suggest you whenever you find time, please go through the interesting documentaries. One such is here, Human Planet. So, today we have discussed carrying capacity, we have discussed the urban carrying capacity and types and the models and approaches to assess, and 2 interesting case studies I believe, Agra from India and Zhejiang province, it is an area. Frankly speaking, my understanding goes that China is actually doing carrying capacity analysis for each and every province. That's the way they are having a very targeted understanding of where they are lacking and how best they can go forward. That's a very good approach. These are the references. Thank you.